Welcome to CEC lectures. Myself Dr. Priti Jagwani. I am Associate Professor in the Department of Computer Science, Aribhat College, University of Delhi. So, in this series of computer networks, in my previous lectures we looked into the different protocols which are Aloha, pure Aloha. Then we looked into the different versions which is slotted Aloha, and we also talked about the concept of CSMA protocol, which is CSMA, collision which is CSMA protocols, and then in today's lecture we are going to cover CSMA CD and CSMA CA, which is carrier sense multiple access with collision detection and carrier sense multiple access with collision avoidance. Now, when we compare these two classes of protocols in the sense like Aloha, pure Aloha and slotted Aloha, and CSMA with its different versions which is CSMA CA and CSMA CD. So, CSMA protocols we can say are definitely an improvement over the previous one which was Aloha, because it has been ensured in CSMA protocols that no station is going to begin the transmission while the channel is busy, because they are carrier sensing protocols. They are sensing before transmission that whether the channel is busy or not, and they are transmitting, stations are transmitting only if the channel is idle or we can say not busy. However, what will happen if two stations senses the channel to be idle and begin the transmitting simultaneously, the signals will still have a possibility of collision. So, now what do we need to do? In CSMA CD, which is collision detection, we are going to move towards our another improvement, which is the station is going to quickly detect the collision, and hence why it is CD, which is collision detection, and abruptly stops the transmitting rather than finishing them. Since these in case of collision, the frames are anyways going to be kind of we can say disturbed, messed away or grabbled away. So, rather than completion of kind of transmission of the frames which we are aware that these are going to collide, it is better to kind of abruptly stop the transmitting. This strategy is definitely going to save the time and bandwidth. Now, in the process of collision detection, what is important? We need to first realize that this collision detection is an analog process. Analog process in the sense the station's hardware must listen to the channel when it is transmitting, and if the channel which it is kind of getting back, it is reading back, is different from the signal which it has put out, it knows that a collision is occurring. So, first of all, stations are need to be kind of trained in the sense that how a collision is going to kind of detected, how a station is going to say that yes, collision has happened. So, it is basically depending upon the signal. If the signal whatever your station is getting back is different from the signal what it has put out, that means definitely collision is occurring. And now these implications are that a received signal must not be tiny as compared to the transmitted signal. Now, this scenario which says that a received signal must not be tiny compared to the transmitted signal is very difficult for wireless scenarios. Now, why it is difficult for wireless scenario? Because your received signal may be kind of 10 lakh times weaker than what the transmitted signal was, and the modulation which we are going to kind of choose in order to transmit, that must be chosen in chosen to allow the collision to be detected. That means a collision of two 0-volt signals may well be impossible to detect. That means different voltage signals should be kind of we can say incorporated. So, this is what your CSMA CD or the working principle or the bottom line of CSMA CD is. So, CSMA with collision detection, that is the basis of classic Ethernet LAN. And when we talk about Ethernet and LAN, mostly I am talking about the wired technology, because as I have already told you that in case of wireless it is difficult, because the received signal may be kind of 1 lakh 10 lakh times weaker than the transmitted signals are. Now, here in this figure you can see how this collision detection is going to happen, and over the whole transmission time there are basically kind of we can say 3 types of different periods. So, one is a transmission period, another one is a contention period, and third one is an idle period, and this is over the whole we can say kind of transmission time. Now, what is happening? Now, let us see this frame which is kind of we can say it is stopping, or it is completion is it is completing its transmission at a particular time T0. Then there are some kind of idle periods over the if you can notice this on the right hand side of the transmission line. Now, this idle period actually is the period of we can say when there is a lack of work on the channel, that means no particular kind of station is going to transmit. Then there are kind of some contention slots or some contention periods. Now, we need to look into this contention slots or contention periods, because transmission period is very clear that a frame is kind of getting transmitted, and as simple they are CSMA protocols, carrier is being kind of sensed. So, a frame is being transmitted at that, definitely at that time no one else is going to kind of transmit because channel is busy. Idle period, obviously that is a period when stations wants to transmit, but what about this contention period? So, when we talk about this contention period, let us say at the time T0 transition period ends and the next frame is sent between this contention period. So, wherever this contention period, you can see the next frame is going to be kind of sent between these contention slots or this contention periods, and this period is the minimum time a host must transmit such that it can be sure that no other host packet it has been transmitting. So that kind of with the help of this minimum period, one can kind of we can say try to avoid the collision, and even if the collision is happening, we are going to detect it anyway, and then that frame transmission is going to be we can say abruptly kind of terminated. Collision can be detected by looking at the power or pulse width of the received signal and compare it with the transmitted signal, as we were kind of just talking about. So, power signal is better than the transmitted signal. The ideal period is that when all the stations are quiet. So, there are kind of consecutive transmission and contention periods. The frame can check if a collision is found, and then the station can check that whether there is a collision which is found, and then they are going to kind of behave accordingly. So, at the point marked which was T0, a station has finished transmitting its time, and any other station having a frame to transmit may now attempt to do so, because one has kind of we can say completed its transmission. So, if two or more stations decided to transmit simultaneously, obviously there is going to be a collision there, and if a station detects a collision with the help of power, pulse, magnitude, we can say it is going to abort the transmission, wait for a random period of time, as we have seen in our kind of earlier what we can say earlier protocols. Then it tries again, assuming that no other station has started transmitted in the meantime, and that period is actually we can say that back off period. So, therefore, the model for CSMA CD is going to consist of alternating contention and transmission period. So, contention is basically your station is actually waiting, transmission is something when the actual frame transmission is happening and along with this contention and transmission period, there are some idle periods. When they are these idle periods are occurring, that means all the stations are quiet, nobody is transmitting anything, or we can say it is kind of lack of work kind of thing. Now, looking into this contention period more closely, we need to look into some answers which are vital to determine the length of this contention period. Now, let us say there are two stations, they both begin transmitting at exactly time T0 when one transmission of the previous frame has just been completed. So, how long will it take them to realize that they have collided, because both have kind of started at the time t0, they are going to collide, definitely. So, how long it is going to take them, or it is going to take stations to realize that the frames which they have just transmitted have kind of collided. So, the answer is important in this context, because on the basis of this answer we need to determine the length of the contention period, and hence what the delay and throughput will be, that is going to depend on this length of the contention period. So, in this way basically we can say your alternative transmission contention and idle time is going to complete transmission line when we talk about CSMA CD protocols. Now, in the starting of this lecture, I have told you that they are this CSMA protocols, or more specifically CSMA CD, which we are just talking about, is yes, giving us an improvement over the Aloha, because they are sensing the channel and then they are kind of sending the transmission. But if we talk about the disadvantage, the main disadvantage is that it is not suitable for long distance transmission, and hence it cannot be used in wireless technologies, because kind of checking the difference between what signal has been put up, what signal they are going to back. So, over a long distance that signal in any case going to be weaken up, and then it is not going to, or the stations won't be able to we can say detect or verify that whether this is a signal which is weaken up is a signal of a collided frame, or it is it's normally got weaken up. So, hence it cannot be kind of used in wireless technologies. If we look into the formal work procedure of how this CSMA CD protocols work, we need to see. So, first of all stations will check that whether the channel is busy or idle. If the carrier is idle, the transmission is carried out, we can say almost immediately. The transmission station, if they detect a collision by using a condition. Now, what is this condition? This condition is transmission delay must be greater than equals to twice of the propagation delay, where transmission delay is denoted by T of t, and propagation delay is denoted by T of p. So, T of t is greater than equals to 2 into T of p. So, the transmission station detects a collision in case by using this condition. Then whenever it detects the collision, the station releases the jam signal as in now nobody is going to kind of we can say transmit its frames and so on and so forth. So, the carrier is kind of jam packed here. After collision has occurred, the transmission station stops transmitting because of this jam signal and all that, and wait for some random amount of time called back off time, and after this time the station transmits again. So, that is basically kind of we can say a simple workflow. Now, this was collision detection, that the stations have detected collision and then they have kind of taken a step back. While if moving with collision avoidance possibility, which is we can say which is described in CSMA CA, which says carrier sends multiple X's with collision avoidance. So, the concept of collision avoidance goes like this. So, collision avoidance is in a network, it has a multiple access method in which carrier sensing obviously is used, because we are talking about CSMA, but the nodes attempt to avoid the collision by beginning the transmission only after channel is idle. So, the basic agenda of stations here is to we can say they try to avoid the collision. Then moving further, we can say your CSMA CA is used in wireless network. Now, please recall we have just seen that CSMA CD cannot be used in wireless network, because the other alternative detection techniques of CSMA CA are not possible, because wireless transmitter is dispensing they receive during the packet transmission. So, because of this thing, if in case of alternative techniques like CSMA CD, wireless, it is not possible in the case of wireless transmission. So, CSMA CA is there to kind of help us, but again CSMA CA is kind of, we can say, it is unreliable because of hidden station problem and exposed terminal. Now, what is going to be the solution of this hidden kind of terminals and exposed terminals problem? So, in this situation we need to employ the solution of RTS CTS exchange. So, RTS CTS exchange says RTS is request to send and CTS is clear to send. So, if a computer wants to send a data to a wireless network, it will check any activity. If it is there, it is going to wait for some time, and then it again checks if there is occurring any activity from other device onto which this channel is being shared. If it is no activity, it sends the data and waits to receive the acknowledgement from the data. If the acknowledgement is not received, the sender will be able to understand that the data has not been kind of received at the receiver's end. Then your RTS CTS also works in this particular manner, like the sender will ask a ready to send a request or a ready to send signal. So, sender is going to give us a ready to send signal, and if the receiver wants to reply it will send clear to send signal. So, clear to send says okay, receiver is ready to kind of receive the transmission, and you can kind of clearly send it. And if which is kind of request to send is as the name indicates, it is a request to transmit the frame from the sender side obviously. So, if this happens, receivers will break all other connection and only make the connection with the sender, and because of this only make the connection with the sender after giving clear to send signal, the collisions can be avoided. So, with the help of this RTS CTS, we are able to avoid the collision on even on a kind of, we can say, a shared channel. CSMA CA is used for the transmission first, and then only it knows about the collision detected. It is used in wireless and wired technology both. So, basically it is a protocol that operates in the data link layer of OSI model. Access method which is used, the access method used by IEEE 802.11 Wi-Fi in CSMA CA. This 802.11 Wi-Fi IEEE kind of standards are upcoming standards when we talk about the Ethernet thing. Now, here we have another idea which says multiple access with collision avoidance, which is MACA. So, this MACA is also kind of we can say this is also a standard, this is also a protocol which is used in MAC layer, which is medium access control layer, and the bottom line or the technology which is being used here is RTS CTS. So, multiple access, so MACA stands for multiple access with collision avoidance. It is, as I have told you, it is a medium access control layered protocol which is used in wireless networks with a view to kind of solve the hidden terminal problem. It also provides the solution to the exposed terminal problem, and the bottom line technology which is being adopted is RTS CTS, and the MAC layer protocol is IEEE 802.11. So, what is the working principle of this RTS CTS when we talk about MACA? And this was also the principle which was used in we can say our CSMA CA. So, MACA protocol works with the condition that the stations are synchronized and the frame size and data speeds are the same. Now, this is actually a we can say it is an assumption under which our MACA protocol is working, that the stations are synchronized, that is the first thing. Frame sizes are the same, data speed for all the other for all the stations is definitely same, and it is going to involve the transmission of two frames which are called RTS and CTS prior to data transmission. So, RTS, as I have told you, is request to send, CTS stands for clear to send. So, let us say that there is a transmitting station which is having a data frame to send to a receiving station, which is so the transmitting station is A and the receiving one, let us name it as B. So, A sends an RTS frame to B. On receiving the RTS, the station B replies if it is in a situation to kind of accept or receive the frame. Your station B will reply by sending a CTS frame in in reply to the RTS which it has received. On the receipt of CTS frame, station on the receive of this frame which is being kind of sent by the receiver, which is clear to send, station A begins transmitting its frame, and after successful receipt of the data frame, the station B will send the acknowledgement frame. So, that means before going into the transmission, both your sender and receiver are on a we can say kind of a common platform, or on a common we can say are in consensus with each other, that one is actually kind of sending a request to send, and another one is replying by clear to send thing. So, in this way your RTS CTS this technique is going to work for your MSCA protocols, and definitely yes, for we also talked about it that it is going to work with this CSMA CA. So, basically if you can see here is a figure which is depicting this RTS CTS procedure. So, there is an station A, as I have told you, that sends a request to send, and then that station, that RTS is kind of sent to the B, and then B is going to reply with the CTS, which is shown with kind of blue color. Then on receiving this CTS, the station A transmits the data, and then when it transmits the data has been received at B, and then B is definitely going to we can say reply back with the acknowledgement, which is in the form of ACK. So, this is actually the kind of we can say figure of this functionality which we imply, or which we kind of which is involved in this MSCA, and the functionalities RTS CTS. Now, any station that can hear RTS is kind of we can say close to the transmitting station, and then the that station remains silent long enough for the CTS, or waits for a certain time period. If the RTS is not followed by a CTS, the maximum waiting time is the RTS propagation time only, but that is in the case when your RTS is not followed by a CTS. Any station who is hearing CTS which is kind of close to the receiving station will remain silent during the data transmission, and it attempts for the transmission after hearing, or we can say only after hearing the acknowledgement. So, this is kind of a way in which the collisions are going to be kind of avoided. So, basically when we sum up this MSCA, we see that it is a non-persistent slotted protocol. Non-persistent in the sense continuous or continuous monitoring is not happening. This implies that if the medium is detected as busy, a station waits for a random amount of period after beginning of a time slot, and then it sends the RTS again. So, this assures the fair access to the medium, and hence why I have told you that this is a non-persistent slotted protocol, and this is what the functionality which is being used in your CSMA CA. That means collision avoidance is the bottom line. So, in this lecture we looked into CSMA CD, which is collision detection. That means the collision is detection only after collision has happened, and then kind of measures has been taken in order to mitigate it. Then another one is CSMA CA, which is kind of employing the functionality of RTS and CTS messages, or RTS and CTS frame, which is basically falls under MACA. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.